Hi everyone, I'm Siti Fairuz, and today I would like to share with you just a piece of our study that titled Designing a Game-Based Learning in Education Physics using Augmented Reality. And this presentation is specifically made of for Mic3St 2022. So let's get started. So this is the presentation outline. Started with the abstract, continue with the introduction, literature review, research method, results and analysis, and conclude with the conclusion. So let's move on to the first section. Abstracts of the study summarize on 4 main key points. First, from the preliminary study that has been conducted for the targeted respondent, which is in this study is the science stream students. So it's highlighted that learning physics is difficult, which is agreed by 73%, and learning physics using textbook only is less enjoyable, where this statement is agreed by 62% of the respondents. So due to these issues, this study is interested and would like to propose a model for designing a physics education application using GBL or game-based learning approach to create more enjoyable learning environment with the assistance of augmented reality technology. So in order to prove the proposed model, so we further design and develop the GBL. So to test the proposed application, we tested it using the usability or SUS testing. So for this stage, the targeted respondent is 30 science stream students from 2 different secondary schools in Malacca. So the results stated that or revealed that 71.83% of the SUS study from the SUS results. So this reflected that the system has a good, strong system usability in terms of its effectiveness, efficiency, and satisfaction. So let's continue to the introductions. Okay, so for the introduction sections in this study, in this paper, we first introduce to the user, to the reader, the nature of learning physics subjects at schools. So the major or the main 3 key points that we would like to highlight in this study is physics subject is less favored and hard subjects to be scored. Few topics difficult to be understood, and if it just only rely on the textbook's explanation, and sometimes the explanation given in the textbooks, specifically physics textbooks, can make the students become more confusing, especially for example in the case of decay topic. And next interesting point that we would like to highlight in the nature of learning physics at school currently in Malaysia, in Malaysia scenario, AR or augmented reality in education field, specifically in physics, it just began. So due to this interesting point, we carry out this study in order to improve lighted in order to change the current learning scenario. So the main element highlighted in this study is first the GBL learning approach, second, augmented reality technology, third, e-game flow model, which is being used or being adopted in designing an enjoyable GBL in physics education. So let's move to the second section of this paper that highlighted on the literature review. So as I mentioned earlier, so this literature review will be further discussed on the 3 main elements of this paper, which is on the GBL, AR, and the e-game flow itself. So let's move. The first section is highlighted or discussed on the GBL concept. So GBL, again, it actually stands for game-based learning, where the educators implement the game elements throughout the learning process. So what is actually the game-based learning that can be implemented, or mostly popular technique being implemented by the educators? First, competition. Second, points. Third, rewards. And last, feedback. So this is cited by, this is study conducted by number 10, research 10. So through the game-based learning or GBL, it's able to motivate the students to stay engaged. And also through GBL as well, it can help to boost the students' self-confidence. And towards the end, it can help to improve the class participation. So move on to the second sections under the literature review or LR. This study covered on the AR concept or augmented reality. So what is actually the AR? Where AR is actually it connects real world with virtual items and it allows real and virtual objects to be interacted either in the forms of hologram or 2D or 3D. And if it's reflected on the current physics subjects, okay, so most of the physics equipment is highly cost to be acquired, to be bought by most of the schools, by most of the secondary schools. So due to this, we implement a study by 17 implement or join or combine the AR technology as one of the solutions. So for example here, it implement AR applications in learning, magnetic fields, educations. And last but not least, under AR, this study also discuss or explain on the AR game, where through the AR game application, it can help to assist students in solving difficulties and completing learning tasks, which towards the end, it can help to enhance the learning experience among the science streams students. So the third section of the LR is covered on the e-game flow model. So this is actually the learning model's guides to measure the learner's enjoyment of any learning games cited by the study number 20. So all the references I shared towards the end of the presentation. So what is actually the elements that can be used inside this model or e-game flow model? There are actually 7 items. First, started with the concentration items, clear goals, feedback, challenge, control, immersion, and knowledge improvement elements. So based on the previous LR that has been carried out, so this is actually the model that being highlighted in this study. Model for designing game-based learning in physics education using augmented reality. So if we all can see, the first element is actually highlighted on the assisted learning tools embedded, which is the AR technology itself, being combined with the learning model that used in this study, which is the e-game flow that consists of the 7 items. And these 2 elements embedded inside the game-based learning. So the subject that being developed, the GBL application that being developed is actually for physics subjects, physics education for Form 5. Specifically, the topic is radioactive decay topics. So under these radioactive decay topics, there are actually 3 subpoints, which are types of radiation, applications of radiation, and decay graph. So the main aim or expected outcome for this proposed model is actually first to improve students' understanding in learning physics using proposed application, and second, of course, in creating or to create more enjoyable learning environments by combining GBL with AR technology. So let's move on to the third section of this study or of this paper, which discuss on the research method. So this research method, so for the development of the systems of the proposed application, we use RAD methodology that consists of 4 stages, started with the planning, user design, construction, and implementation. So this is the overall GBL flow chart. Okay, start with the main interface and it have few functions inside it. Okay, so move on. This is the overall GBL design process. Started with the designing the storyboard, designing the contents of the GBL itself, implementing the audio and or sounds, and also to finalize and to build the .apk version. Move on to data collection, instruments, and data analysis used in this study. So this study is actually a quantitative-based research where it involved 30 science stream students from 2 different secondary schools in Malacca. So as I mentioned earlier, we're going to test on the usability of the system. So the instruments that we use to test the usability known as the SUS questionnaire suggested by study 22 and consists of 10 items. So below is the list of the 10 items that being used for the SUS questionnaire. So this is the interface or for the home page of the proposed GBL application named radioactive topics. Okay, so this is where we implement the AR element inside the GBL application, where it highlights first on the smoke alarm concept, fertilizer AR concept, hearts AR concept, and dice AR concept. When the user played the AR functions, actually there is actually a sound and also a story that being played to the user. So because as I mentioned earlier, the main purpose of this study is actually to improve the enjoyment of the learners to learn physics education. So this highlighted on your right hand side is actually the implementations of the e-game flow model, where as we already recap in the literature review, e-game flow model is actually a model that being used to highlight or as a guideline that being used that can help to cater the enjoyment element in the learning. So this is an example of the event that happens in while the learners play the radioactive topic applications catered or group under each of the e-game flow elements, 7 elements, started with the concentration, having a clear goals, giving a feedback to the user when user are taking the quiz, the challenge, the control, where it lets the user to control the games, the immersion, and also the knowledge improvement. So the results, move on to the results and analysis. So results of this study reflected that, okay, because we're going to test on the SUS. So this is the first figure is actually the SUS skills result by question, because just now we said that there is actually 10 items. So this is all the summary from the 30 respondents answered by the response answered by the 30 respondents. We group by each of the SUS items or SUS elements, and this is the total of SUS score. So based on the guideline of analyzing the SUS, for this study we get 71.83%, which is falls under the we can say this system reflected having a good SUS. So this can be said that the proposed application has a good strong system usability in terms of its effectiveness, efficiency, and satisfaction of the respondents when learning, especially radioactive topic, using augmented reality approach. So, as the conclusion, the main goal of this study is to implement the GBL, game-based learning, and AR or augmented reality technology into learning physics educations, where it helps the targeted outcome is actually to help or to enhance the students' understanding and enjoyment was achieved. So GBL is actually still a new educational platform and medium for students to get educational knowledge in a more enjoyable environment. Recent study also proved that GBL is a revolutionary tool for educating students. And finally, the proposed model can be used to teach and entertain learners, and it can be made more attractive by adding more 3D models on a different subtopic, especially for in learning physics subjects. So with that, I'm share with you the list of the references, so you guys can refer to here. And with that, thank you. Thank you for your time and thank you for listening to my presentation. Have a good day, everybody. Bye.